In the last section, we were becoming familiar with the periodic table. We were looking at how each element is similar and each element is different. And so we know on the periodic table, every element has its own number of protons, its own atomic number. That's what determines what the element is. We know whatever its atomic number is, it has an equal number of electrons because atoms are neutral. But we also know that the electrons are not just randomly around the atom, they are in energy levels around the atom. And electrons on the outer energy level, the valence electrons, are the ones that determine if an element is going to be reactive or not. Okay? And we know that everything over here in group 8 or column 8, the noble gases, we know these are very stable, that is, they do not react chemically because they fill up their outer energy level. The rest of the atoms are not like that. They don't have full outer energy levels, so they can actually react. They can change. They can form what we call chemical bonds. And we're going to take a look at chemical bonds in this section. So let's start by looking at a sodium atom. Okay, sodium is an alkali metal. Remember, that means it's in column 1A. It's got one valence electron, and it's very, very reactive. Let's actually go ahead and look at sodium-23. Okay, so sodium has 11 protons because it's sodium. Sodium-23, remember the 23 is the mass number, so that's the combined number of protons and neutrons. So 11 protons, 23 minus 11 gets me 12 neutrons, and because it's a neutral atom, it's also got 11 electrons. So if I'm drawing this atom, my protons go in the nucleus, 11p plus, my neutrons go in the nucleus, 12 neutrons. There's my nucleus right there. Now, no electrons go there because it's the nucleus. Around the nucleus, I get electrons. And the first electron goes here, the second electron goes here. But the first energy level only holds 2. So now I need a new energy level. So I'm going to draw my second energy level right here, and I'm going to put electrons on it. Now I need to get up to 11, but this one only holds 8. So I'm putting in my 8 valence, or my 8 electrons. Okay, so that gets me a total of 10 because I have 8 here and 2 there. I need one more, so I need a third energy level, which is why sodium's in the third row on the periodic table. And then here's my last electron. That's 11. 11 electrons, just like I said. One valence electron, one outer electron, which is why it's in 1A. It's got one valence electron. But this isn't stable. Right? They're stable when they have 8 valence electrons. They're non-reactive when they have 8 valence electrons. And this doesn't have 8 valence electrons. It has 1. Okay, but it's really close to having 8. And I say that because if this electron right here were to go away, if we could take this electron and send it over here, then this energy level would be empty. So we could ignore it. We could say it's not here anymore. Okay? So here's this atom without this energy level. But we have an issue now. If I do that, I don't really have a sodium atom anymore because an atom is neutral. And this thing no longer is because it has 11 protons but only 10 electrons. Okay, so it lost an electron and it became stable, but it also gained a charge. Right? 11 pluses and 10 minuses leaves me with a 1 positive charge. It's got 1 extra proton compared to electrons. So this thing is actually overall charged. It's got a 1 plus charge. That's okay. It just means it's going to have to probably find something negative to stick to later. Okay, so sodium does that. Sodium has 1 valence electron, and it'll actually give away 1 valence electron to drop down to a full energy level. Do you have to go through this rigmarole every time? No, there's an easier way, right? If you go to sodium and find it on the periodic table, it's in group 1. Remember, we draw electron dot diagrams for these things. It's in group 1A. So all I really have to do is go, okay, sodium is right here, 1 valence electron. It can lose that electron, and then it looks like this because it's got no dots around it, no electrons left, but it has a 1 plus charge. Okay, so sodium 1 plus is an ion of sodium. Okay, so what we mean when I say ion, it's a charged atom. Okay? And the way an atom becomes charged is by gaining or losing electrons. Okay, so forms when electrons are lost or gained. Now, what we just saw was a sodium atom losing an electron. Okay? And it turns out metals tend to lose electrons. And if you think about that, let's go back to the periodic table. The reason metals lose electrons is because the metals are in group 1 and group 2 and group 3. Group 1 and group 2, they're going to have electrons, just 1 or 2 or 3 electrons in that outer shell, which means it's easier for them to lose 1 or 2 or 3 than to try to fill their outer shell to 8. Carbon is right here in the middle, and everything in the middle has 4. These actually tend not to ionize. That is, they don't gain or lose electrons. There's another thing atoms can do to become stable, and we'll take a look at that in another unit. But these guys, they tend not to ionize. But these next 3, like let's take a look at chlorine. Chlorine is element number 17. We'll look at chlorine 35. Okay? So if we draw a chlorine 35 atom, chlorine 35, it's got 17 protons, 18 neutrons, and because protons and electrons balance, it has 17 electrons. So 17, 18 protons, neutrons in the nucleus. Then I have my first energy level. That's going to have 2 electrons. My next energy level, that's going to have 8 electrons. And my next energy level, which is going to have 7 electrons. So let me fill those in. 1, 2, and then 2, 4, 6, 8, and then 1, 2, 3, 4, 5, 6, 7. Okay, so that gets me 2 and 8 is 10, and 7 more is 17 electrons. So that's where I'm at. But you'll notice this poor electron doesn't have a pair. There's an open spot there. There's no electron there. So that electron that that sodium atom just lost, it could actually come and fill in this spot right here. And that would make chlorine stable because now it has 8 valence electrons, but it would also make chlorine charged because now chlorine went from having an equal number of protons and neutrons to an unequal number. It's got 17 protons and it's got 18 electrons, which gives it 1 extra negative. It gained a negative when it gained an electron. So this went from chlorine with 7 valence electrons, so its electron dot diagram would look like this. And then an extra electron came in, so it changed into chlorine with 8 valence electrons, 5, 6, 7, 8, but now it's a 1 minus ion because it's charged. It's got 1 extra electron. It's got 1 extra negative charge. So this is the ion that chlorine forms. And the nonmetals tend to do this. The nonmetals tend to take in electrons. The halogens in group 7, they'll take 1. Oxygen is in group 6, and it's got 6 valence electrons. That leaves 2 open spots, so it'll take 2. Nitrogen and the nitrogen family, they have 3 open spots. They'll take 3. So if we come back to this, okay, so metals lose electrons, and they form positive ions. Okay. Now, a positive ion is called a cation. The nonmetals gain electrons. Okay, that forms a negative ion, and a negative ion is called an anion. Okay. Now, how do I remember cation versus anion? Well, a negative ion is an anion. Okay? Cations are positive ions, anions are negative anions. Or anions are negative ions. So let's just do a quick example of figuring out a couple different ions that might form. So let's consider aluminum. Aluminum's a good one. Okay, now you don't need to draw the whole aluminum atom. Okay, if you go back to an aluminum on the periodic table, let's see, we'll clear all this stuff out of here. Okay, aluminum is right here in group 3A, so it has 3 valence electrons. And it's to the left of that zigzag line, so it's a metal. So that tells us right away, aluminum, 1, 2, 3 valence electrons, it will form a cation, that is, it'll give away all 3 of those electrons. It'll change into aluminum with no valence electrons, which is really the same thing as having the undershell full, but now it's a 3+ ion. Okay, so that one's not so bad. Let's look at oxygen. Oxygen is going to form an anion. Okay, Oxygen is in group 6A, so it has 1, 2, 3, 4, 5, 6 valence electrons. Okay, it's got 2 open spots. It's got an open spot here and an open spot here. So that tells us it's going to take 2 electrons. So, whoops, not A, O. So oxygen will actually take in and fill in those 2 open spots and have 8 valence electrons and be stable, but because it gained 2 electrons, it's oxygen 2-. Remember, positive ones are cations, negative ones are anions.